So the length of BM and MC is half of BC. So let us write half of BC here. BM is equal to MC is equal to half of BC, which is half of 24, which is 12 centimeters. Okay. So let us just do this in fair a little bit. This length is 12 and these two lengths are 12. And I assume let the radius of the circle be R. Let the radius of the circle be R. Therefore, what if the radius of the circle is R? That means OB, this dotted line that you see, this is also R. OA is also R. So you write OA is equal to OC, OB, not OC. OA is equal to OB is equal to R. Okay, so both are equal to R. And what about uh, the length of this AM? The length of this, what about this entire length, AM? We can find out with the help of Pythagoras theorem, because you know this is the right angle triangle. This triangle is a right angle triangle in which this is your hypotenuse. Length of the hypotenuse is 12 root 5. The length of the base here is 12. Therefore, you can find out the length of the perpendicular. So let us apply Pythagoras theorem and find out the length AM. So we write in triangle AMB. In triangle AMB. Hypotenuse is AB. So AB square is equal to AM square plus BM square. AB square is equal to AM square plus BM square. You know that the length of AB here is given to be 12 root 5. The length of BM is 12. So this is 12 root 5 square. The length of AM is 12. And sorry, the length of the AM we have to find out. So we write AM as it is. The length of BM is in fact 12. So this is 12 square. So let us now find out the length of AM. So this is 12 square into root 5 square is equal to AM square plus 12 square. That means this is 5 into 12 square is equal to AM square plus 12 square. You can find out 5 into 12 square as 5 into 144. Multiply, you can find out the product. But let's try it an easier way. That is AM square can now be written as 5 into 12 square minus 12 square. Now you can take 12 square common and you get 5 minus 1. So this is 12 square is 144 and 5 minus 1 is 4. Okay. So you leave it as it is. We don't need to multiply 144 into 4 because both are perfect squares. So you can write this as 144 you can write as 12 square and 4 you can write as 2 square. So this becomes 12 into 2 whole square. Therefore, what is AM? AM is square root of 12 into 2 square, which is 12 into 2, which is 24 centimeters. So with the help of Pythagoras theorem, what we have done is we have managed to find out the length of this altitude here, AM. This length we have managed to find out. If you know this length as 24 centimeters, this entire length as 24 centimeters, and if you know this length as R, then what should be this length? that is OM. We're talking about OM here. What is the length here? Length is 24 minus R, right? Now you consider this right angle triangle. This right angle triangle now you consider. If you see in this right angle triangle, this is your hypotenuse, this is your base, and this is your perpendicular. So from Pythagoras theorem, now we write in triangle OMB, in triangle OMB, you have OB square, which is the hypotenuse, is equal to OM square plus BM square. We have OB square is equal to OM square plus BM square. So what is the length of OB? Length of OB is R. What is the length of OM? Length of OM we have already found out here to be 24 minus R. And what is the length of BM? Length of BM we have found out to be 12. So let's put it here. Okay. So now we proceed to solve this equation. There's a square here. We proceed to solve this equation. We get an equation in R, and we proceed to solve this equation to find out the value of R. So R square is equal to, you expand this by A minus B whole square formula, A square minus 2 into A into B plus B square plus 12 square. That means R square is equal to, now how much is 24 square? 24 square is 576. Yes. 576 minus 48R plus R square plus 144. So now here what happens is that R square and R square will cancel from both sides. We only left with 48R is equal to 576 plus 144. So 48R is equal to 720. That means R is 720 divided by 48. Now you can cancel here with say 6, and I think this will cancel with 8 also. 15. The radius of the circle is 15 centimeters. Any questions on any part that you could not understand? If no, then I'll proceed to the next problem. Okay, so let me just summarize this problem a little. We considered this triangle first, AMB, and we found out this length, AM. We considered the radius of the circle to be R. So this is R. And therefore OM, this length, is 24 minus R here that I have written. And then we considered this small right angle triangle where we knew the length of the hypotenuse to be R, we knew the base to be 12, and we knew this to be 24 minus R. So we, with the help of Pythagoras theorem, we formed an equation in R here. We formed an equation in R, simplified it to find out the value of R and solve that equation. Okay. So that is what this problem is all about. Let us see the next question now. Now the next question, in fact, number 11 is also the same in as number 10. You can solve it number 11 exactly as number 10, because here it is an equilateral triangle. So here also it's no problem, because if you draw an altitude, there again it will bisect the chord and it will pass through the center. So number is 11 is exactly as number 10. Okay. Uh, yes, this number 14. Number 14, if you read the question, it states that the length of the common chord of two intersecting circles is 30 centimeter. If the radii of the two circles are 25 centimeter and 17 centimeter, find the distance between the centers. Let us understand the concept of intersecting circles first. What do you mean by intersecting circles? Two circles are there. These two circles are called intersecting circles. They intersect at what points? They intersect at the points A and B. Okay. A and B are the points of intersection of these two circles. Let us say that P is the center of the circle and Q is the center of this circle. And next what is given is that there is a common chord of the two circles. Now what do you mean by common chord? See, this is the common area. This is the common part of the two circles. In this, if I draw a chord from the points where the circles intersect, that is they intersect at A and B. So from if I join A and B, this chord is common to both A and B. This chord is common to both A and B. Okay. So this kind of a chord is called a common chord of the two circles. Okay. And the length of this common chord is given to you as 30 centimeters. That means AB is given to you as 30 centimeters. So we write AB is equal to 30 centimeters. Fine. Radii of the two circles are also given. The radii of the two circles are given to be 25 centimeter and 17 centimeter. Now what do you mean by radii? Radii, if we join these two, this will become radii. These two will become the radii of the circles. These two will also be the radii of the circle. This is another radii and this is another radius of the circle. Okay. And what are the radii? Length of the radii given? The length of the radii are given to be, this say is given to be 25 centimeter. So let us assume AP to be 25 centimeters and the other radius is given to be 17 centimeters. So we write, let us assume this to be 17 centimeters. This is 17 centimeters and this is also 17 centimeters. And the length of this chord AB is also given. Okay. The question here is find the distance between the centers. So what do you mean by distance between the centers? Distance PQ is the distance between the centers. Okay. So what I do here is, first of all, I join P and Q. In fact, what I do is I drop a perpendicular from P on AB. Draw PM perpendicular to AB and QM perpendicular to AB. So if I draw here a straight line which is perpendicular, and if I draw here, okay, so PQ will be the distance between the two um, centers. Now the question here is obviously that if I have drawn these two lengths, this is just a quiz. If I have a straight line, if this is my center P and if this is my center Q, if I draw a perpendicular from P, say it meets at M, and if I draw a perpendicular from Q, it can meet at N also. Then why should M and N be the same? Can anyone tell me why should PQ be a straight line? Why can't they be two different lines? Can you tell me why should it be a single straight line? Why can't it be two different straight lines? Sneha, can you tell me? Sneha Chaurasia? Anyone? Shikha? Sonam?
No, sir, I don't know.
Okay, fine. It should be a straight line because if you draw a perpendicular PM from here, if you draw a perpendicular, this length is 30 centimeters, right? This is given to you, 30 centimeters. Then this should be 15 and this should be 15, because you know that any line through the center of the circle which is perpendicular to a chord must bisect the chord. So therefore this must be 15 and this must be 15. Again, from Q, if you are drawing a perpendicular, similarly this must be 15 and this must be 15. So therefore P and Q both have to be on the same straight line, because PQ will bisect this chord. Any question?
Excuse me, sir.
Yes.
So please can you repeat it once more?
If I have, suppose this is your common chord, say AB, that I have drawn above. Okay, let me just scroll up a little. Okay, AB. This is your common chord. Okay, and you have a point P here, center of a circle, and you have point Q here, center of another circle, P and Q. If I draw, if this length is given to you, this entire length is given to you as 30 centimeters, right? If I draw a perpendicular from here on AB, this length will be 12, and sorry, this length will be 15 because it is 30 centimeters. This length AB is 30 centimeters, so therefore this will be 15 and this will also be 15. From Q, if I draw a perpendicular, this length will be 15 and this length will also be 15. So therefore PQ have to be on the straight line, on the same straight line. Is it possible that I can have 15 length as this and 15 length as this, and I can have 15 length at this at the same time? You cannot have, right? So therefore PQ has to be on the same straight line. Understood?
Yes, sir. Thank you.
So this is what is meant by this problem. Now once we are clear with this, that PQ will be a single straight line, now we shall proceed to find out the distance between the centers. Now what is the distance between the centers? It is PQ, but it is also the sum of the lengths of PM and MQ. Now let us proceed to find PM. How do you find PM? First of all, you know AM to be 15 centimeters. How do you know AM to be 15 centimeters? Because it is half of the length of AB. So let us write AM is equal to MB is equal to half of AB, which is half of 30, which is 15 centimeters. Okay, so this is 15 and this length is also 15. And you will give your reason. Reason is any line through the center, any line through the center perpendicular to a chord bisects it. Right? Now you consider this right angle triangle here. If you consider this right angle triangle here, you see that this is my hypotenuse. Let me write, this is my hypotenuse, this is my base, and this is my perpendicular. I know the length of the hypotenuse, I know the length of the base, so I can find out the length of the perpendicular. So you can, by Pythagoras theorem, you proceed to find out the length of the perpendicular. So we consider triangle PMA. In triangle PMA, AP square is equal to PM square plus AM square. Okay. Now AP square, length of AP is the radii of the circle. So you know this to be 25. Okay. And PM you don't know. So you'll simply write PM here, PM square. And AM square you know as 15. So AM square is 15 square. So that means PM square is 25 square minus 15 square, which is 225. Sorry, 625. 25 square is 625 minus 225, which is 400. So that means PM is square root of 400, which is 20 centimeters. So we have managed to find out the length of this PM here. Okay. Now we proceed to find out the length of MQ. In order to find out MQ, you can consider this right angle triangle here. So we are talking about AMQ. So in triangle AMQ, which one is the hypotenuse? This is my hypotenuse. Okay. This is my base, 15. And we need to find out MQ, which is the perpendicular. So AQ square is equal to AM square plus MQ square. Just put the values here. AQ square is 17 square. AM square, if you see in the figure, AM is 15, right? 15. And MQ we need to find out. Okay. So MQ square will be 17 square minus 15 square. 17 square is 289, if I'm not wrong, right? Yes, 289 minus 15 square is 225. And if you subtract, you get this as 64. So therefore, MQ you get as square root of 64, which is 8 centimeters. So what you see here is that you have got the length of PM as 20 centimeters. So this length PM, you have got 20 centimeters, this entire length. And MQ, you have got the length as 8 centimeters, this MQ. This you have got 8 centimeters. Therefore, what is the distance between the centers? 20 plus 8, which is 28. You write hence distance between the centers of the two intersecting circles PQ is equal to PM plus MQ, which is equal to 20 plus 8, 28 centimeters. Okay, any question in this problem?
No, sir. No question, sir.
Fine. Now, if you have no questions, then I'll stop here for today.